Hello everyone, and welcome to section 5 of the series, Demystifying Fiber Optics with the Fiber Wizards. In this section, we will give you an overview of basic cable systems and processes for fiber optic installation. It is important to keep in mind that there are many applications in which fiber optics are used, and the example that we'll use today only describes a very simple plain old point-to-point link typically used in outside plant environments. To learn more about fiber uses and installation in other network environments, visit our website or contact us for more information. Ready? Let's go. All right, so the drawing that we see here depicts a very basic example of an outside plant end-to-end link. All optical links begin and end with connectors, which serve as interfaces to the electronic equipment. In between the connectors, we have the main path or cable route, which is defined according to the topology and physical elements that we find along the route. As the amount of cable that can be stored in reels is limited, additional cables might have to be added and spliced for interconnecting electronics over long distances. There are many types of outside plant cables. However, in most, the design and characteristics are defined by either mechanical stress factors during installation or factors related to climate or the installation environment. Another key factors are that fiber cables must have adequate moisture protection and, when required, armor to protect against rodents or to add impact or crushing resistance. Whenever cables have metallic elements in them, these must be grounded according to any local electrical codes or applicable standards. In North America, one of the biggest causes of fiber damage are the American squirrels. For some reason, they seem to love chewing on fiber cables. I imagine that maybe in other parts of the world there might be crocodiles, or who knows, maybe even dinosaurs. So choose cables with appropriate protection wisely to prevent outages. A very important recommendation when working with outside plant cables is to use tools that are designed to make access and preparation easier. Tools that are specifically designed for cable access are generally safer, as well as help to save time and prevent accidents or damage to the cables than using your standard pocket knife. There are also many types of cables that are specifically designed for inside plant or premises cabling. Using cables without the appropriate flammability rating for the installation environment will result in the propagation of fire or the release of toxic fumes in the event of fire. Please consult local regulations to ensure compliance with safety codes as well as to protect lives. Inside plant cables tend to be designed for facilitating installation of connectors and tend to be a little easier to open than most outside plant cables. Even so, it is always recommended to use specialized tools to make your work easier, safer, and to prevent accidents with the cables. Another important process used during the installation of fiber optic systems is the process of splicing, which is used for concatenating fibers to give continuity to other fibers or for connector installation. The most recommended splicing method is fusion splicing, which requires of using high-precision cleavers and electric arc fusion machines. Here is a brief demonstration of how fusion splicing is achieved. First of all, the heat shrink protection must be installed into one of the fibers to later use for protecting the splice. The fiber must then be stripped and cleaned with appropriate chemicals such as isopropyl alcohol or fluids that are specifically designed for fiber cleaning. After cleaning the fibers, the ends are cut with a precision cleaving tool. Once the fiber is cut, it is immediately transferred to the fusion machine to avoid contamination by airborne dust particles. Once the fibers are placed in the fusion splicer, the rest of the process is generally automated. When the fusion is finished, it is very important to inspect and verify that the splice was made as expected and not to fully trust the estimated loss given by the machine. When the splicing process is completed, the protection sleeve is placed over the splice and transferred to the oven for shrinking. Once the sleeve shrinks and cools down, the splices are stored and protected in trays inside connectivity hardware. In addition to splicing, another critical process in the installation of cable systems is the connectorization of the fibers. The connectors contain small cylinders in the middle called ferrules, which are used for aligning the fibers with precision. Most of these ferrules are made of ceramics and are polished with the fiber at the tip to achieve a mirror smooth surface finish. This is to maximize light transmission through the connector and to reduce any potential loss or reflection that could impact the quality of the connection. To make connections, the connectors are mated with mechanical adapters. These have precision sleeves inside for aligning the connector ferrules and giving continuity to the fiber links. The process demonstrated here is being completed with a Fusion Splice-On connector. This method has become very common due to the simplicity of the process and its results. With this method, the connector polishing process is performed in a controlled environment at the factory, reducing the complexity of preparation in the field while increasing the consistency of results. Lastly, to complete an end-to-end link, we will need connectivity hardware. The main purpose of connectivity hardware is to protect the cables and the fiber connections. Also, to provide interconnection access for other network elements and test equipment. These generally consist of closures and trays with adapters that provide connection points for fibers and other network elements. When installing fiber cables in connectivity hardware, it is important that these are well secured and that the fibers are well organized to avoid attenuation problems due to bending. Alright folks, so this concludes the overview section of fiber optic cable systems and basic installation processes. Please take a few moments to complete the corresponding quiz. And when ready, please continue with the next section.